Saxon's Trig, Lesson 66, Formulas for Systems of Equations, and then phase shifts and period changes all together in one problem. In Lesson 62's video, I mentioned that you had equations that you could memorize, and that's what they're giving you here in Section A, Formulas for Systems of Equations. Since it is a repeat of what you knew from before, they're going to start out by having you just write down what they're going to call their official formula. So for x, it is the second b multiplying with the first c minus the first b multiplying with the second c, and then the denominator is the first a multiplying with the second b minus the second a multiplying with the first b. And as soon as I find it, I'll give you the y's equation. Oh, there it is. Okay, so y equals the first a multiplying with the second c, see they're super similar, minus the second a multiplying with the first c all over first a, second b, that part's the same, minus second a, first b. So the denominator is the same, the numerator has differences. And again, as I said in Lesson 62's video, I do not prefer to memorize these formulas to use them. However, now you have them. If you wish to have them officially in your notes, there you go. And in example 1, it says, use the formulas to solve for 3x plus 2y equals 8, 4x plus 5y equals 3. So normally if we were given two equations with two unknowns, we would solve by substitution or elimination. This also said in the paragraph, use abstract coefficients to find a formula. We're not going to go through finding the formula again. There's the formula. And then use the formula to solve for y. So now I know that I want to use the y formula and plug these numbers in to get the answer. Okay, so the first a is 3. The second c is 3 minus the second a, 4, the first c, 8, denominator, first a, 3, multiplying with the second b, 5, minus the second a, 4, multiplying with the first b, 2. Okay, so now we simplify. 9 minus 32 over 15 minus 8. So the denominator of 7 and the top negative 27. Let me check that. Oh, wait a minute, that doesn't feel right. 23. Now let me try that again. 9, 12. Yes. Negative 23 over 7, and that does match with the book. So you see how simple it is to use the formula if it's sitting right in front of you, but memorizing it and using it, I just feel it's awkward, and I would rather do substitution and elimination, but whatever. In part B, we are now going to combine phase shifts and period shifts into one problem, and you already know how to handle both of those, so this should not be new, except for the fact that your equation will have something like a number for your shift and where you began instead of 0, plus b here is representing the height, and then either the word sine or cosine depending on where it's starting, c being a number multiplying in front of your theta or x, whatever they're doing, and then minus a d. So this is how the equation looks if you've got both a phase and a period shift, or you can have the word cosine in there. All right, so example 2, write both a sine and a cosine equation for the given sinusoid. So we are given here, let's see, center line, oh, they didn't label it. Lower point is -1, high point is 7. I have a 45 degrees, and I can have a start here. Okay, they only showed 3 sections and they showed it ending at 450. It was at the high point here. So they have low point, center. Okay, so they've got the curve doing this here. And now let me label, this one is negative 90 degrees. And that's a high point. It's smack in the middle of my 7. All right, so anyway, hopefully that's enough information to do the 2. If not, I'll add more to it. All right, so it says sine and cosine. So let's start with our sine one. Y equals, what is the center line? It didn't tell me, but we're going to find it. So what is the distance from 7 to negative 1? That's a total of 8. So half of that is 4. 4 things below 7 is 3, or 4 things above negative 1 is still 3. I'm going to skip the plus or minus part, fill in that we just found that the height was 4. We are doing sine. Okay, so at 0, I'm not starting in the center, obviously. So the closest center one, because the center one over here would be 225. So that's going to be 45 degrees. So, oh, and I didn't label example 2. This is an arrow with an X, positive X. That's what I thought. So this is going to be X rather than theta. Because I'm starting here and going down, I can fill in my minus. And then because this is positive 45, we will fill in minus 45 degrees. And that, oh, and then I didn't check to see if there's a number in front to see if my period has changed. So I need to pick a starting place and an ending place to see if what my 4 sections are happening in. So this one is, I mean, I could start here, which is the same place I started, but I didn't carry it far enough here to show. So I'm just going to do peak to peak. Even though those are cosines, it's still the same 4 sections. So from negative 90 to 450 is a total of 540, and that most definitely is not 360. So we are going to take our 360 divided by the 540, which is the period that it actually accomplished the 4 sections in. And that's reducing, I am looking for the reduced, 2/3, yes, okay. What was the number that went into those? So, you know what? Let me just go down by 2's. 2 went in here 18 times. 2 went in here 20. Oh, no, hang on. It's 27. I knew that couldn't be right. What would go into 18 and 27? 3. So that would be 6 and 9. And then what goes into 6 and 9? 3 again. So that's 2 and 3. So that proves that it's 2/3. I had used the book before to look. And then that 2/3 gets filled in front of the parenthesis here. And there is my sine answer. Now I think they did it to a different start. Yeah, they used the 225 as their starting place. They did not use the closest one to 0. And I said that's kind of my preference, but it's not perfection. So they had a plus sign here and they had a positive 225 because they used the negative 225 to start. All right, let's do the cosine one now. We know that the 3 and the 4 remain the same. Center line and height aren't going to change. And that period of 2/3 isn't going to change either. And this is now going to X. And because it's cosine, I need to find where it's starting at above or below. So this one at the above is the negative 90. The one above over here is way further away. So I'm going to start with the negative 91 and fill in plus 90 degrees here. And because that's at the top, I know that this is a positive. Oh, this one I happen to match the way they chose to do it. So these are the answers for sine and cosine, where you have both a phase and a period shift in the same problem.